Hello all, I am Shravan and this is my ELP101 project. The topic I'm doing is making a low pass and high pass filter using a series AC RC circuits. In the following you can see resistor, a capacitor in which Vout is along different components in different pass filters, and an input signal. A low pass filter. A low pass filter allows signals with low frequency to pass but impedes the ones with high frequency. The low pass filter is created using a series RC circuit with Vout along the capacitor. In circuit, the high frequency input impedes and the low frequency input passes and finally reaches the ground terminal. This is a circuit, a low pass RC series circuit, where you can see a capacitor, a resistor, V output along the capacitor and an input signal, and the I current. How does this happen? In our circuit, we see that Vout along capacitor will be Vout is equals to Vin times Xc over R square plus Xc square to the power 1 by 2, where Xc is 1 by 2 pi Fc, where F is the frequency and C is the capacitance. Xc here is also the impedance of the capacitor. So if we use a high frequency signal, the Xc is small, then R by Xc becomes large and hence Vout becomes smaller, due to which high frequency signal is impeded, as we can see in the formula. Similarly, when a low frequency signal is used, Xc is large and hence R by Xc is small, due to which Vout is high and we can see proper Vout and it passes and is not impeded. So this graph shows the Vout by Vin in decibel variation with the angular frequency omega, which is equals to 2 pi f, where f is the frequency. We can also see in the graph that omega b, the breakpoint angular frequency, is equals to 1 by Rc. When this occurs, the decibel becomes minus 3 decibel, the Vout by Vin. The break frequency is when Xc is equals to R and hence Wb is equals to 1 by Rc. When this happens, V output is equals to Vin by root 2, which is 0.707 Vin. And when we use the decibel formula, then 20 times log 0.707 becomes minus 3 decibels, nearly minus 3 decibels. So now we talk about a high pass filter. A high pass filter allows signals with high frequency to pass but impedes the ones with low frequency. High pass filter is created using a series RC circuit with Vout along the resistor. In the circuit, low frequency input impedes and the high frequency input passes and finally reaches a ground terminal. This is a circuit showing the high pass RC series with capacitor, resistor and Vout along the resistor. How does this happen? In the above circuit, we see that Vout along resistor can be Vout is equals to Vn times R over R square plus Xc square to the power 1 by 2. And here Xc is equals to 1 by 2 pi Fc, where F is frequency and C is capacitance. So if we use a low frequency signal, the Xc is high, then hence Vout becomes smaller, due to which low frequency signal is impeded. Similarly, when a high frequency signal is used, the Xc is small and hence Vout is high, and we can see proper Vout and it passes and is not impeded. This shows the graph of modulus of Vout by Vin and decibel variation with normal frequency. Here we can see the Fc is equal, the omega is equal to 2 pi Fc, and when omega becomes 1 by Rc, the decibel becomes minus 3 decibel and the frequency becomes 1 by 2 pi Rc. The break frequency is when Xc is equals to R and hence Wb is equals to 1 by Rc. When this happens, the Vout is equals to Vn is equals to 0.707 Vn and decibel becomes minus 3 decibel. So the conclusion, we saw that series AC RC circuit can be used as both high pass filter and low pass filter depending upon the R value and C value and the Vout positions. So this was my report. Thank you for watching the whole video.